So why this design? Why a cut-on contact?
What I actually saw in penetration testing and flight testing is that not only width but length hurts you in penetration, I believe. I think it's that added surface area as you're trying to push it through, any tissue or anything. That added surface area is not really helping you out.
Okay. So you've created a non-vented version.
I did.
And it flies, it performs similar to this?
So far so good. Aaron Snyder, I gave him some. He shot it at 60 and then 100 yards and said, these are great. He really liked it. Most people would think, and I would have also 10 years ago, that you can't have that high a hardness. It'll be brittle. You can't achieve the impact strength you need with that. And that's what really I learned through going through 5 different steels. Sharpness matters. And, okay, maybe you're hitting the shoulder blade, but you also have to slice through all this tissue through the animal. And that's where a sharper broadhead is going to shine and out-penetrate one that's not sharp.
All right, folks, welcome to the Gritty Bowmen podcast. I'm sitting here in Evergreen, Colorado with Bill Vanderheyden. Is that how you say it?
Yes, Vanderheyden. Very good.
Vanderheyden. And he is the owner of Iron Will Broadheads.
Right.
Right? And you actually live in Colorado.
I do. Yep. I live near Loveland, Colorado, so...
Not far from here.
Hour and a half north of here in the foothills.
And, you sent Aaron and I this Iron Will Broadhead to try, I think it was like July, August time frame, something like that, before we went on some of our hunts this last year.
Right.
And it was a favorite. We talked about it on the podcast. So we actually used it a bit this year. Aaron used it quite a bit. I was in camp with a lot of people who used it.
Okay.
And saw what it could do. So give folks a little background on what this broadhead, its design, and, how you came up with it.
Yeah. So maybe to give you a little bit of history, so I'm a mechanical engineer, and I'd been doing product development, manufacturing, engineering for many years, and had a bad experience with an elk. And I shot a little too far forward and hit the shoulder blade. And broadhead I was using, failed. Got very little penetration. And I'd worked really hard to get to that point, and pretty devastated by that. And I really took on a lot of responsibility for that, I think, thinking that, that shoulder blade is so close to the vitals where you're aiming that you really need a broadhead to perform and make it through that shoulder blade, make it to the vitals. So as a design engineer, I, pretty quickly understood the broadhead I was using had some weak points and some failure points. And I kind of took it upon myself to use my engineering ability to find a better broadhead or design a better broadhead. So I spent a couple of years researching, kind of doing, going through the math and physics on a lot of the things related to archery and broadheads and impact, and testing a lot of broadheads, and really found something I didn't like about each one of them, and then started trying to just engineer my own to make it better. And it was a several-year process, really. Did initial design and tried to use all the engineering tools that I would use, in my engineering job. CAD solid modeling, and then, finite element structural modeling, computer simulations to figure out, where is the high stress areas? Where should I put material? What's the best geometry? How do I balance thickness between blades and ferrules? And really kind of take an engineering approach to everything along the way.
So why this design? Why a cut-on contact?
Yeah, so I was always a 3-blade guy. I just had it in my head that 3 blades would fly better, be better balanced, something like that. But, as I really looked at the physics of it and as I tested it, I wasn't really seeing that with the flight. And the 2-blade definitely out-penetrated. I did a lot of penetration tests on different 3 blades, different 4 blades, 2 blades, through different materials. My brother, Tim, helped a lot through this time. He was with me when I had that, when I wounded that bull, and he did a lot of the testing along the way with me. And one thing we saw that was clear is that a 2-blade or 2-blade with bleeder out-penetrated a 3-blade. And that's really what kind of switched me over to starting to look at 2 blades. And And I initially designed it without the bleeder because if you just want maximum penetration, that's all you care about. You can't really beat a 2-blade cut on contact. What we saw is occasionally we'd get a poor blood trail. Not a lot, but once in a while. Just about a single slice through it. I just think sometimes it can close up. And my brother Tim really pushed me on that. He shot more animals than I had with him at that point. And it was the right thing to do. I was in denial for a little while, but then when I finally added the bleeder blade, 3/4 inch wide cut, set back from the blade a bit, it didn't really decrease penetration very much in our testing, but huge difference in amount of bleeding, the blood trails, the holes staying open. So I'm a big fan of bleeder blade. I don't think I'd shoot a 2-blade again without a bleeder, just because I've seen, if you keep that hole open, there's a lot more blood comes out. And you're also adding 3/4 inch cut as well.
There's a couple other broadheads that look similar to this to me on the market.
Yeah.
How is this one different?
Yeah, probably primarily the materials.
Okay.
And, the geometry as well. It kind of would depend on which one you're talking about. But
yeah, definitely geometry is different.
Yeah.
I mean, it's still got it's a cut on contact with bleeders. But it doesn't quite have this geometry.
Right. So one of the things I learned, going back to the research, and historically there was this thinking that a 3-to-1 ratio was best for penetration. I still hear that a lot from a lot of the trad guys, that like 3 inches long, 1 inch wide kind of thing.
Right.
Long pointy end. And what I actually saw in penetration testing and flight testing, is that not only width but length hurts you in penetration, I believe. I think it's that added surface area as you're trying to push it through, any tissue or anything. That added surface area is not really helping you out.
Okay.
And over the years, my broadhead got shorter and shorter, and the Tonto style tip, that second angle tip, came further and further back in. And
what's a Tonto style tip?
That's where you have, like a Tonto blade knife or sword, instead of having just one angle all the way out, you have a second angle at the end.
What you have right here at the tip.
Right, at the tip. It has a larger angle at the tip than it has through the rest of the blade. And that makes the tip much stronger. That's one of the failure points I saw when testing other 2-blade heads that had just a constant angle all the way out, is that the tips would break on bone impact. So by bringing that in, that's like an 80-degree angled tip. It makes it a very strong tip. And, I saw that through the structural analysis as well.
I saw a head similar to this that doesn't have that angle and hit a hard surface, and that tip did, bend, fold right in half.
Right. So another thing there is the materials. I spent a lot of time testing different steels. I was going for, initially I was really going for max penetration through bone. So I was trying to achieve a number of things, but one of them was max penetration on big animals like elk. Being able to go through a shoulder blade or go through bone undamaged, stay sharp. And then I started working on sharpness as well. I started realizing that a lot of broadheads aren't that sharp out there, depending on what process they use to make them.
Yeah, that's a huge complaint of mine. I'm like, I don't understand. When I buy a box of broadheads or a package of broadheads and I get them out, I just feel like it's a broadhead. It should be razor sharp.
Right.
And a lot of the ones I've pulled out in the recent year, I'm very disappointed by how sharp they are, or how sharp they are not. And there's a few brands where I'm like, dang, right out of the box, these are razor sharp.
Yeah.
And the design of some of the other ones may not be that bad, but they're not on the same level of sharpness. And when I've gone and used them, a sharp blade, I just don't think you can underestimate the value of a sharp blade.
Yeah, I totally agree. And that's something I learned over the years, because I was thinking the same as you, that, hey, you buy a package of broadheads, these are going to be sharp. Of course they're going to be sharp. Turns out, no, they're not often. And especially the one-piece solid 3-blade broadheads, typically they have, they want to have the flat grind. So they have a 30-degree per side angle. Well, just that angle itself is hard to get very sharp. Nobody's going to make a knife that's going to be sharp and cut well at 30 degrees. They're all 20, 22 degrees, maybe 25 degrees. So a 30-degree angle is harder to get sharp to begin with. And then depending on the manufacturing process they used and, when it's one-piece solid, I think it's just more difficult to grind the edges as well. On this one, we do a 3-stage grinding on, we've got 6 edges, double bevel, so we end up doing 36 grinding setups. And, I mentioned a bit about material. So the harder you have the material, so a high hardness. So they measure that by, how much you can dent the surface with a certain force. So it's really kind of a compressive strength at the surface. The higher you can have the hardness, the sharper you can get the edge, because you can get a really fine edge because the material is just that strong.
Yeah.
And then it retains the edge better. So a harder one, it takes more to wear that edge away. So these are 60 Rockwell C hardness, and that's what somebody would shoot for. A custom knife maker might want to have just kind of the ultimate edge that they can get really sharp and have excellent edge retention. I don't think any other broadheads are close to that out there for hardness. They're usually 50, 52, and that's a world of difference, really, 50 to 60 Rockwell C hardness. So we can get a sharper edge and better edge retention. Most people would think, and I would have also 10 years ago, that you can't have that high a hardness. It'll be brittle. You can't achieve the impact strength you need with that. And that's what really I learned through going through 5 different steels. And then once I settled on A2 steel, also spending about a year just working on the heat treat process to try and achieve both the high hardness for edge sharpness, edge retention, as well as excellent impact toughness. So even though it's that hard, our impact toughness is 3 to 5 times the other blades out there, the material. That's just the material. And then with the 60 thousandths blade thickness, that gives you more strength as well.
Right. Okay. So I used this last weekend I was in Texas hunting hogs, and I shot this giant hog, Hogzilla. And
I saw that. I saw the picture. Congrats.
Thanks. I had a lot of options for broadheads. I got a drawer full of different ones to choose from. But throughout this last season, I've messed around with a variety of heads, from mechanical to, fixed blade, 3-blade, to this cut-on contact. And I'm finding that I'm leaning toward a cut-on. I don't know if I'm right or wrong. All I know is that I'm leaning toward a cut-on contact blade because I'm getting a lot better flight and a lot better penetration with that setup. But I also, so on that hog hunt, I used a dirt nap broadhead, which looks a lot similar to this, kind of with the bleeders and stuff. And when I shot the target, but I bent it pretty easily. I mean, it was I don't know which model it was.
Yeah, I'm pretty sure dirt nap, and I think it's a good broadhead for the price. Cut on contact with a bleeder. I mean, I like the general design. I'm pretty sure dirt nap uses 420 J2 stainless steel. So it's just a lower end, lower cost blade steel. And you can't achieve that high hardness, high impact strength with that material. It costs a lot less to make, and that's why they can sell it for less.
Right. Yeah, because the one complaint that I get from people on this broadhead is the price tag.
Sure.
And those dirt naps are definitely less expensive. But I will say I shot the pig, and it was a quartering away shot, and I purposely waited for that shot so I could get behind the shoulder, behind the shield plate there, the cartilage plate. Went through the whole body diagonally. Probably I didn't check for sure, but I'm sure it went through both lungs, heart, the just diagonal slash. Came out right behind the front shoulder on the opposite offside shoulder. And when that broadhead hit the other side and hit that plate and some muscle and whatever in that shoulder.
Yeah.
Definitely slowed down the arrow. It was like, I'm sure it just, because it ended up having 6 inches protruding out each side as it ran off of the arrow. So it passed through, but the arrow didn't go all the way through. I mean, once it popped through, it stuck in the body cavity. And it ran about 80 yards and died. And the arrow fell out about 10 yards from where he went down. So it worked its way out. But that blade, I'm much more interested in penetration than I am in diameter of hole. I used to think a lot about the diameter of the hole I was making, but I'm finding 2 holes are better than 1, 100% of the time.
I totally agree. I think there's a number of misconceptions out there, and I think that's one of them. You know, a big entrance hole beats, an exit hole. I totally disagree. I think, a big animal like an elk, if you take out one lung, you're probably not going to find it, at least not that day. Mm-hmm. So I agree. You want the penetration, you want the 2 holes, and, better blood trail with a second hole. But I just think a pass through all the way through the vitals is what you want.
And, I mean, I am taking, I like a quartering away shot. I like shot options. And I feel like with some of these heads, like the expandable ones, for example, you're getting a giant hole, but when you're shooting diagonal across an elk's body or a big buck, I want that hole to go all the way through it, the whole way through and out the other side. And the diagonal body cavity on an elk is large.
It's huge.
It's a long way for that arrow to go. And I'm finding that the broadhead makes a big difference in how far that goes. The other thing is, I don't want a broadhead that catches on bushes or trees or branches or glances off them, because I'm finding, in a real world scenario, I'm up against shooting through some brush. Mm-hmm. Might not be that thick, but it's still some brush, and I don't want a head that either has an angle on the broadhead that's so steep that I feel like it pushes it off track, the arrow off track, or where it's mechanical and it deploys and gets caught on branches and crap on its way to the target because it's got this giant 2-inch, blade sticking out.
I'll probably never hunt with a mechanical myself. Really, as a design engineer, whenever we develop a product and before we'd launch it, we do this DFMEA, we call it, which was design failure modes and effects analysis. Basically, look at the design, think of what all could go wrong. Mm-hmm. How do we test it to see if it's going to go wrong? How do we design it to make sure it doesn't go wrong? And I think mechanical or expandable broadheads, there's just too many more things that can go wrong. Why would you want to add in that risk if you didn't need to? And I think a lot of guys do it because they shoot better for them. They can shoot them long range, and some guys it's because they want a really wide cut.
I think for some guys it's because it's more tech. That's appealing. It's just like, look at how big this hole could be, and they envision that without realizing how much momentum is required to really make that broadhead deploy and cut a hole through the entire body cavity.
And like you said, a quartering way shot on an elk, that's a long way to go through.
And if you only get a foot in there, you could be just past the guts, maybe liver, maybe, diaphragm, and it doesn't even get to the heart, doesn't get to the lungs, doesn't get to, a lot more.
Right.
And so to me, I'm just the mechanical side of the house. I'm sure there's some that, I used a few this year, and when they worked, they were devastating. But, an animal might get hit with that, and it literally falls over in eyesight, where with some of these that have a lot more depth penetration, the animal might go a little further, but it's 100% dead.
Yeah, and, you mentioned sharpness before, and that makes a huge difference, I've seen, because when I first started making prototypes, I was hand sharpening. I probably hand sharpened the first 200 of these. And I got to the point where, in about an hour, I could get them shaving hair really well. Then I started quantifying, how do I quantify sharpness? And I would zoom up the edges to 200x to really try and quantify the sharpness and improve it. And what I saw over the years, the sharpness has improved about 10x from where we started. Now I can zoom it up 200x and it still looks dead sharp. I mean, I know that one way I measure sharpness is I try to measure how much of a flat or radius there is on the very edge under very high, magnification scope.
Yeah.
And I know that down to a 10,000th of an inch, there's no radius or flat on there. I mean, it's that super sharp. But what I've seen from that too is that over the years, I know the blood trails have gotten a lot better, and I know the animals are dying a lot faster. The last several animals, for sure, I've just seen them. Another thing, I think it zips through them, and they don't hardly know they're hit. Like when you're cut with something really sharp, run a little ways and drop dead in sight. And that's kind of my goal is, place it where I want to and get a quick, clean kill.
Okay.
And so I think sharpness matters a lot. And that's why if you take nothing else from this podcast, make sure your broadheads are sharp because, like you said, a lot of them aren't that sharp out of the package.
No, I agree. I have there's this post I want to share with you that I read that I thought, you would like, that I think it really benefits everyone who's listening. There's this post that T-Bone Turner did where you'll see it right here where they throw that baseball and it hits that bird and it just explodes. I mean, it's just insane to see that baseball go and then boom, bird is just pieces. But what he said was, he said something about, I've been saying this for years. This is, bow hunters take note. It says, why kinetic energy doesn't matter. Cape Buffalo with a baseball. In the late 1940s, U.S. military trauma surgeon Dr. Frank Chamberlain researched the theory of shock waves produced by bullets traveling over 2,500 feet per second. The term used to describe the wave was hydrostatic shock, and the formula used to measure the bullet's potential wave was kinetic energy. Dr. Chamberlain never used the kinetic energy formula to determine bullet penetration. Instead, Chamberlain determined that kinetic energy killed through hydraulic effect shock wave, which that was produced by a supersonic projectile. Hydrostatic shock killed by trauma to blood cells, not by hemorrhage from bullet penetration. So for those that are listening, hydrostatic shock is a lot different than what you do with a bow and arrow.
Right.
And this is way out of my league, but when you're using kinetic energy, what he's trying to measure is how effective that hydrostatic shock is. And so when it hits the animal at, such and such speed, it does something to just, you're the engineer.
I'm not the medical guy. I've got medical people in my family, and they kind of explain some of that to me as well. But right, with a bullet, you're getting this shock. You're shocking the tissue and damaging a lot of tissue just from the shock itself. And
the way someone explained it to me once was like, you're made up of water. Like an animal, a human, you're like 90% water. And so when that bullet hits the hydrostatic shock, like all the water in your body gets displaced from the impact point. And that water turns into a million little projectiles that move out of the position that they're supposed to be in and just explode outward.
Yeah, it destroys
a
large area around the wound channel through shock. And with broadheads, you don't get that. You need to slice tissue to kill it. And that's why if the broadhead is not very sharp or if it's just a blade that doesn't retain an edge very well, by the time you get through the hide and the rib, if it's not sharp, you're tearing or pushing tissue aside more than slicing
and more than cutting it.
Yeah.
He said, on the other hand, Dr. Ed Ashby's 30 years of arrow penetration research quantified momentum, arrow mass, and forward of center, FOC, as true predictors of penetration at arrow impact. Ashby's research especially holds true when heavy bone is encountered. Arrows and broadheads kill through laceration or hemorrhage created by penetration, not hydrostatic shock. The deeper an arrow penetrates, the higher the chances of lethality and animal recovery.
Yes.
So the deeper that arrow goes, the more lethal. This video demonstrates your point. In South Africa, the government requires bow hunters to produce 80 foot-pounds of kinetic energy to hunt Cape buffalo. A Major League Baseball weighs 2,300 grains. Using the formula for kinetic energy, basically a pitcher can throw 100 miles per hour is legal to hunt Cape buffalo with a baseball. Ask yourself, with that high of a kinetic energy number, 114 foot-pounds, how far do you think a fastball will penetrate a Cape buffalo? Kinetic energy is potential energy with no direction. It has no relevance in determining arrow and broadhead penetration. Tag a bow hunter who loves kinetic energy. So, it's I think there's a lot of misconceptions around arrows, broadhead, flight, all that kind of stuff. But the one thing that I think holds true with what he said was, and you know it from common sense, you're not killing an animal with hydrostatic shock. When you're sticking a knife in something, the sharper it is, the deeper it will go. And it doesn't take very much pressure to push an extremely sharp object into some animal tissue. It takes a lot of pressure to put a very dull object into tissue.
Definitely.
So that sharpness is critical.
It is. And that's what a lot of people miss that in the durability testing too. There's a number of guys that on YouTube channels will just do durability comparisons and Ironwood Broadhead does really well in those, but a cut on contact in general doesn't do as well as a really blunt, say a 3-blade or something that's not as sharp, because for breaking through a bone, sharpness doesn't matter very much. So if somebody's doing a test just showing, how does it stand up to shooting into a concrete block, or how does it stand up to shooting through a bone, and then people choose those as their best broadhead, I stress also need to look at sharpness. And I've talked to a couple of guys doing those tests saying, hey, something you're really missing here is that sharpness matters. And okay, maybe you're hitting the shoulder blade, but you also have to slice through all this tissue through the animal. And that's where a sharper broadhead is going to shine and out-penetrate one that's not sharp. So I think a lot of people miss that as well.
Yeah, I would agree. There's so many, there's so many different broadheads on the market.
Oh, there are. I went to ATA and there must have been 15 different broadhead companies there.
Oh, more than 15. Hundreds. You can flip through like a Cabela's catalog and you're just blown away by all the different options out there. Some are so gimmicky, I feel like it's insane. But one thing I find interesting is this broadhead you've got right here is basically the same thing. That same design is like a flint broadhead from, 1,000 years ago.
Yeah.
Like there's got to be some tried and true.
So, I try to just use good engineering methods of not taking what I was having a gut feel or thinking would be best, but actually make some data-driven decisions as I went. And that's what I ended up with. And so it's a proven design. I have some flint broadheads that don't look a lot different than that, as far as just general shape.
Right.
It's modern materials, modern engineering in the blades, extremely sharp, high impact toughness, great blade edge retention, the ferrule material, grade 5 titanium, in the 100 grain. And why? Well, because it has a great strength to weight ratio. Why don't other people use it? Well, it's really expensive. It costs 5 times as much to make that ferrule. I've had it quoted in 70-75 aluminum or 303 stainless, which are the typical materials. It costs 5 times as much, but it has for 100 grain, it's hard to make a strong steel ferrule because it weighs so much more. You just don't have a lot of material there.
Yeah.
So I really think the titanium ferrule is the way to go on the 100 grain. And then our higher weight ones use a hardened stainless steel to basically match the strength and toughness.
So, with this broadhead, like, how much do they cost?
They're 3 for $99.95.
Okay.
Yep.
And why that price point?
Yeah, so a majority of that is just the materials and manufacturing processes. So I get that a lot, that hey, these are way too expensive. Well, in reality, you're getting a great deal, is my feeling. But I didn't really set out to what I really set out to do here was make the ultimate broadhead, because I love to bow hunt. I mean, and so do my family and friends, and I just wanted to make the ultimate broadhead to take kind of broadhead failure out of the equation. There's so many things that can go wrong bow hunting. I didn't want broadhead failure to be one of them. So I had this design done, and it was about a 7-year process of iterating on the design before I settled on this one. And then we had this design done and hunted with it for about 3 years. And I wasn't really planning to come to market because I thought it would cost too much for people to buy it. And I had a partner initially in this, Eric Whiting, and
I know Eric.
Yeah, we met up in the mountains in a remote basin, both elk hunting, and got to be friends. He saw me take a couple of elk with this, and just really impressive. One of them was this quartering away shot, and it entered right at the hip. It was kind of swinging, just walking slowly as I shot, and blood right at the hip where it entered, and it went all the way through the heart and poked out in front of the between the shoulder and the brisket out in front.
That's a lot of tissue.
A lot. That was I don't know, 4.5 feet of it was a big ball, 4.5 feet of elk, and a year later he saw me shoot one. It's a cow at 54 yards and hit her right where I was aiming. It zipped right through her and stuck in the dirt 10 yards past her. She went 10 yards, looked around and dropped. And he said, "Man, you got to take that to market." And I said, "Well, you want to be my partner?" Because I have no interest in doing the sales, marketing, all that kind of thing.
Yeah.
And because I've worked at a number of companies, as well as startup companies, I knew that designing a great product is only, you're not even halfway there. Getting it out and getting people to know about it is the other half. So I really credit Eric with doing that.
Okay.
He spent, we both worked pretty hard for about 2 years at the launch. And he really took care of the sales, marketing, website kind of thing. We're still good buddies. We're going to hunt together, and he still works for the company a little bit, but he's gone on to pursue his marketing career with Backbone Media, and he really wants to do that. So that's great.
Yeah. Well, so this head right here, so you guys came out with it and then pushed it, and then how has it been received?
Oh, yeah. So maybe I didn't answer your question on price. So how do we come up with that price? Majority of that is actually materials manufacturing cost. I'm just pricing it at a point where I want people to use it and buy it.
But you're not getting rich off
most
it.
company models would be, they'd sell for $200.
Yeah.
Because they're looking to have the manufacturing cost be, 25-30%.
Right.
Really? At most.
It's like Heather's Choice food. There's just not a big profit margin.
Yeah.
On what she's doing because she wants it affordable for people.
Right.
Once it gets beyond that, but there's not a lot of room when you decide you're going to make something of X quality, of a certain level of quality. It costs more. There's not a lot of room for profit beyond that.
Right. There's not. And
have you considered making a less expensive version of this using different products?
We did. Eric and I did, and I didn't want to go that way. I don't want to compromise. That's one thing I've always wanted to do is just make the best engineering decisions. Because in most companies, I would come forward as an engineer and say, "Hey, we can make this X amount better if we change this material, geometry." So would it make it better? Yes. Would we make any more money off of it? A lot of times not. It's hard. Marketing guys, their feeling is, well, perception is reality. It's more what the customer perceives being good or bad, more so than is it really better or worse. And so even though as an engineer, I know it's going to be better. It's hard to justify, well, can you sell it for more? Maybe not. Are you going to sell more of them? Maybe not. I'd have to deal with that a lot as I worked for other companies. And in this company, I wanted to make the decisions that made the best broadhead, best performance. And to be honest, I was hoping to just kind of not lose money and do side engineering work as needed to pay the bills. But it's been amazing how many people have used it this past year and are, saying positive things about it and how well it's been received. So I really feel like this next year, it is my main job now, but I think I'll have to do less, other work on the side.
Yeah.
So looking forward to that.
That's really cool. So when Aaron and I use these, one of the only performance complaint we had was around the noise. We would get a little bit of, flight noise when we shot it compared to a couple other ones we were shooting that were just quieter.
Right.
So, since then you looked into it.
Right. So, Aaron called me, told me about that. I came down, shot the broadheads with him, and, he said, "Hey, these broadheads are loud." I'm like, "Really?" So, I listened to him shoot them, and, if you listen really close, you could hear this shh, shh, kind of a hiss, with the air going through it. So,
some broadheads, they even whistle.
Okay.
I've heard them like, as they go, like the G5 Montec.
So, a buddy of mine,
there's a few that just, and, you put them on a different arrow, different fletching configuration and so forth, and some of them are quieter. I don't know why, but sometimes these vented broadheads just make noise.
They do, and that's really what I found out. A friend of mine is a sound engineer. He develops high-end microphones. He came out with a system, and we set it up at the archery range with 4 omnidirectional microphones, measure sound equally in all directions. And I shot through them with 13 different broadheads, different vanes, feathers, and we measured the sound amplitude over time and compared them all. And what we saw in general is vented blades are a little louder than solid blades, just the air flowing through there. And, as you said, I think it can be affected by bow speed. Generally, a little faster bow, it's more of an issue. Maybe a crosswind where you get a little bit more of an angle of the air coming through the blades is my theory there. But what I really learned from all that is that you get this loud noise at the sound of the bow, and then it's really very quiet at the target until the arrow's almost there, and then you see this flare up of sound, and that's where you'd see a difference. Just this last yard or two before impact, that last hundredth of a second, you could pick out by overlaying the sound tracer, you could pick out, the loudest versus the quietest broadhead, say. From that, my conclusion was that an animal isn't really going to have time to react. He can react to the bow noise, the sound of the bow at the shot. There's enough time for that, but I don't really think there's enough time for him to react to, this broadhead blade or vent or vane is louder than this other one. I think it's too late. But what I also learned through there is that I can make them quieter by just getting rid of the vents. And so I made some prototypes there. I tested them. It was one of the quietest broadheads I saw, and so I decided to go forward with a non-vented version. And it was really you guys bringing that up and pushing it a bit, and Aaron Snyder pushing it a couple of times, saying it sounded like a 747 on a Gritty Bowmen podcast.
Yeah, I think he said that.
Like that.
And at certain times it was just louder, and other times a little quieter, probably, like you said, crosswind.
Also, if you're on the side of it and in front of the guy shooting, it's much more noticeable than if you're behind him or something like that.
Right. Yeah, we'll go down and stand by the targets, which no one should ever do this. And we'll get behind something, and then we'll listen to it come. And you can just hear with your own ears it's approaching. I think I had someone quoted to me that a deer moves at 1,300 feet per second is how quick it can move. So,
well, I've done the math on just let's just say he pulls his legs up and drops, because that's a lot of times what deer do.
Right.
Can he? And let's say you're at 30 yards away. I think it was 40 yards away. It'll take maybe 0.3 of a second from the bow noise to where it impacts, and that is enough time that a deer can just free fall drop 6-8 inches in that time. So I agree. They can move with the sound.
Well, we were finding that It's like when I was in Texas with Sloan from Backbone. We were shooting. I recorded some shots on does at 240 frames per second, and I was able to, like, from the time the shot goes off to the impact, those deer can move a full foot in various directions. I mean, it's insane how fast.
Yeah.
And you can see the arrow going, and you see the deer move out of the way, not trying to dodge the arrow, just trying to escape, just leave.
Yeah.
And the speed is insane. So we've talked about it. We prefer like a 40-yard shot with some of these twitchy animals, because sometimes, they don't react to the sound of the bow as easily.
They're more likely to look than just bolt.
And then when you get beyond that, 50, 60, 70 yards, 80 yards, you're dealing with them not really reacting to the sound of the bow, but they hear the arrow coming. And I shot at a Kuzbach this year at around 80 yards, and it was a good wind kind of up where I was at. I shot the bow, and he was just kind of standing there. And as that arrow came, you could see his ears just come alive, and then he just was like, and he moved. And the arrow went right through an empty space.
So my theory on that is that, because I've seen videos of that where people say, well, it didn't react to the sound of the bow, but it reacted sometime later, like to the sound of the arrow. And so at 40 yards, I think it takes 1/10 of a second for the bow noise to get there. And then there's some reaction time. I think so let's say it takes 1/10 of a second for that. I think they say human reaction time is 1/10 of a second. Animals are maybe twice that fast, depending on the size of the animal. So that's like 0.15 seconds out of the 0.3 it takes to get there before he can react, before he can hear it and start moving. So that's my theory on why sometimes it takes a little while. And that arrow is getting louder the whole way. Because, the noise is like R squared at the distance. So it's getting exponentially louder as it gets closer.
Right. That's what I've noticed when I'm downrange of one of Aaron's trad bow arrows. At first, I hear it go off, and it's like, oh, yeah. And then it gets closer and closer, and then I cannot help but flinch and duck. And I'm a human with pretty slow reactions. And yet I will still flinch and duck uncontrollably, as it comes closer. It's just instinctive. So I think they just have ears and an ability to hear even more. Now that's a trad bow with feathers and a much slower arrow. And
one thing I saw with feathers is that, when I mentioned there was really pretty quiet, you could overlay them till the end, and then there was this flare up. Feathers was the exception. And it was flared the whole way.
Loud.
It just loud the whole way. And in fact, the guy that was the engineer he'd be hiding behind his van down there during the shots. He'd come out, what was that? What was that? And I'm like, oh, that was just feathers.
Yeah. So you've created a non-vented version.
I did.
And it performs similar to this?
So far so good. I've been shooting it. Aaron Snyder, I gave him some. He shot it at 60 and then 100 yards and said, these are great. He really liked it. I've got some more guys shooting it right now, some more independent testers that are going to do the 80, 100-yard shooting, and really do a head-to-head, the vented, non-vented, to see if they're as forgiving. We know the vented one shoots really well at long range. I'm hoping the non-vented does as well. The theory there is that more surface area, more susceptibility to, say, crosswind having an effect on it.
Yeah.
Things like that.
Yeah, I can't shoot like Aaron. I mean, I have my days where I'm pretty dang good, but I don't, on a live animal situation, I might crush a 3D course at 90-yard shots and plus. And sometimes I can lay them in there shot after shot on a course like that. But on a live animal, with the nerves and the intensity and the heart pounding and just the rush and the excitement of it all, it's hard for me to make those kind of shots at that range. Just a physiological experience.
Yeah, I've been shooting the broadhead, the solid version, a lot at 40, 50, 60, 70 yards, and I'm convinced it shoots really well.
Yeah, that's all I need.
And to go beyond that, it takes a shooter better than me.
Yeah.
I think to really say. I mean,
yeah.
I can't. I have good days, and I'm holding something like this at 80 yards or something, but there's better shooters than me that can tell you that. So.
Yeah. Well, I mean, that's all I'm getting at is I don't really need it to go 100 yards because I'm not really shooting that far. There are guys that are. I mean, I got some this week who I did the review on the Garmin Zero sight, where it's a rangefinder, calculates the range and drops a pin like a
right. I saw
pin.
that at the film festival,
and so I tested that out, but I got a few emails from people that are like, "Hey, does it go beyond? Does it range out to like? Can you get a pin for like 120 yards?" I'm like, no, it kind of caps out at depending on the shooter, like 90 yards or so.
Okay.
So if a guy wants to have a setup where he needs to have a sliding pin sight in order to go beyond,
because you just don't have the field
you
of
just
view
don't have
for
the
that.
field of view in there
Okay.
to put it in.
That
put
makes
that
sense.
on there. And depending on the speed of the bow, I mean, it can vary, right? But
right.
That is, or the speed of the arrow. That is, but there are guys who hunt out to 120 or so yards, like Tim Gillingham, guys that are much better archers than I, and that matters to them. But for me, I'm finding, 50 yards and in is kind of my bread and butter. And that's kind of the experience I want to have anyway. So as long as that broadhead just penetrates like crazy and flies accurate at those ranges and puts a giant hole and exits two holes in the body, it's kind of I'm liking all that.
Well, I designed this originally for max penetration on elk, and really that was a lot of what I was going for. But I also really like shooting mule deer, and I'd learned over the years. I used to have a 40-yard, kind of max range limit, and I just was missing all these opportunities at 50 to 60 yards on mule deer. It just seemed like I couldn't pattern them like the whitetails I grew up hunting.
Yeah.
They're just unpredictable, and I was getting longer shots. So I did a lot more long-range shooting, extended my range to 60, 65 yards, and then I've gotten mule deer 5 of the last 6 years, I think now, and I got one at 40, but they've all been 50 to 65. It seems like that's a sweet spot on how close I can get those things. So that's one of the reasons I spent a lot of work on long range flight, and basically the compactness is what gives you that. It's the width is 1 1/16 wide, main blade, 3/4 inch wide bleeder, but the overall length is only 1.2 inches. And it's that overall length that helps as well to reduce the surface area and reduce the planing effects.
Yeah. Well, very cool. Very cool. I'm excited to shoot them and see how they fly and how they do. It's fun to just kind of experiment a little bit and see what's out there. When you have a warranty on these?
Right. Lifetime warranty. Kind of no questions asked. If you damage it, break it, we replace it.
And so the guy just has to send it in and you'll replace it.
Yep. Yeah. Send it in. Contact me, send me some pictures, send it in. I like to get them in and do a little, failure analysis, see what happened. And really we sold thousands this year, and I've got back maybe 10. And the biggest problem is, two main causes so far. People shooting one broadhead into another one in their target and putting a little dent in the blades. The other one is shooting through or just hitting a rock, and still doesn't break it. They still spin true. What you'll do on a really sharp cut on contact is you'll smash that edge in a little bit, and you can sharpen it out, or you can just use it as a practice one. But we've been replacing everything, so that's part of the reasoning on why you should pay $100 for 3 is that, you can keep using it. That's something that it was never, I never thought about doing.
As long as you don't lose it.
Right.
It's forever.
Right. I think Snyder, said he told me over the phone, he shot 4 deer with the same broadhead before he hit a rock and then quit using it.
Yeah.
And could still shave hair. I know I shot, few years ago, I shot 2 elk with the same broadhead. Could shave hair with it. So, yeah, it's you really can reuse these. Just spin them, make sure they spin true, and you can touch up the edges and keep using them.
Yeah. Well, that right there might be enough to that you'll actually spend less on the broadhead in the long run. I mean, most of the ones I put through an animal, they were one and done.
Right.
Almost all of them. And so you say you spend $30-$40 on a pack of 3, sometimes more, and they're one and done.
Well, I think that's the mindset.
Like I've recovered
everybody.
Nearly all my arrows that hit an animal. I mean, pretty much all of them. So, with this broadhead, if I had been using it, they just keep on going. They
do. And, you can touch up the edges. I've got some videos on our YouTube channel showing how to do that. But now we've had enough requests. We're selling replacement blades too. So you can put a new factory sharp blade in there as well if you want to.
Oh, that's nice. How much are the blades?
They are, I think they're 3 for, I don't know, I'll have to check, 3 for $40, something like that.
Yeah, that's a lot cheaper than replacing an entire broadhead.
It is.
Yeah. All right. Well, very cool. Is there anything you want to close with? Anything you want to throw out there? Closing.
Yeah.
Where can people get a hold of or find your what's your website?
Sure, yeah. So the company name is Ironwell Outfitters. The product is Ironwell Broadheads.
Okay.
You can search on either of those websites, but ironwelloutfitters.com or ironwellbroadheads.com will take you to the same page. And yeah, check it out. We've got a lot of information on there about some of the materials used in engineering there. So yeah,
good place.
Give it a try.
Do you have an Instagram or Facebook?
I do. Yep. At Ironwell Outfitters is the Instagram.
Okay.
And search on Ironwell Outfitters for the Facebook as well.
Very cool. Well, Bill, thanks for coming on and sharing your story.
Well, thanks a lot for having me on, and I really appreciate you guys giving them a try last year.
Yeah.
When I saw that Gritty Bowmen podcast and you talked about Ironwell Broadheads, that was a big surprise to me, and I really appreciate that. All of a sudden, our volumes tripled last August when you came out with that, so I appreciate that.
No problem. Yeah, anybody that's coming out with a new product that helps a hunter be more lethal, I think it's cool. I think it's cool to investigate, experiment with, test. And what I've learned more than anything in the last couple of years, though, is there's just you can do so much testing inside a lab and in theory, but you learn so much when you actually use something in the field for a long time. And there are some products that just crush it when they just live up to the theory and the expectations that they carried. And then there are some that just fail miserably in a real world situation, be it clothing, a pair of boots, whatever it might be. And there's nothing like real world testing to figure out something's weakness.
Well, the one thing, I looked at a lot of different broadheads at ATA this year, and almost everybody's using the same materials, very low cost materials, because really at that price point, you can only put a few dollars cost into making a broadhead. And I don't blame the manufacturers. They're just doing what the public is used to. I mean, people are used to having a broadhead cost $10 or so each, and because it's disposable. And so I think there's, I think I'm doing something different there and trying to use the high-end materials, the best engineering, and this is where I got to price it at. If you like it, buy it. If you don't, that's fine. And one other thing I'd say is that being in in this industry in the last year, getting to meet a lot of guys in it.
Yeah.
Oh man, I love it. There's so many good guys in this industry that we share the passion for hunting, and that's been a lot of fun. I mean, I've really enjoyed that. I didn't expect, and then the other thing is helping so many people be successful. I've probably had 20 guys tell me that they got an animal that they wouldn't have got with another broadhead. We had 2 guys shoot Yukon moose through the shoulder blade and get quick kills on them.
Yeah, I had some bad experiences this year that frustrate me because of the broadhead. broadhead played a major role. And that's why I slowly shifted throughout the season to shooting just fixed blade, and then over time, really enjoying the cut on contact blade, like this design right here. Mm-hmm. I mean, I'm a big fan of that. And then but I gotta admit, I like that G5 striker. They feel sharper than most broadheads right out of the box.
Yeah, they've got that's the one with replacement blades, right?
Yes.
Generally, replacement blades are pretty sharp. Not sure if those are Lutz blades or not, but the angle on them, they can get them pretty sharp. They're probably not going to be as durable or retain the edge, maybe, like this will. But if you just want a sharper broadhead, the replacement blade broadheads are generally pretty sharp.
Yeah, so. I was surprised. I mean, as I got a lot and I tested them and I pulled them out of the box, that striker was one of the few that were actually sharp out of the box. And they're not cheap either. The angle of the blade, I'm not sure. I'm a big fan of just if I'm shooting through brush or something like that, but,
you shoot through brush, huh?
I do. I mean, it might be controversial, but when you grow up hunting in the Northwest and you got a blacktail buck through like some blackberry bushes 10 yards away, it's like, I usually try to find that window and I usually try to make it through, but, it's not a lot of brush. And I mean, a lot of the guys I know that are like born and raised, and these guys that are Angry Spike Productions that are hunting Roosevelts, they're shooting through ferns and some bushes. And I mean, and when I hunt Prince of Wales Island for black bear, it's like, it's just not the kind of country where you get an open country shot. And so, I want something that has a heavy front of center. It's a heavy arrow, and that has a fixed blade, because trying to shoot in Oregon, fixed mechanical is illegal. Never used one there. Never used one in that kind of thick country until recently. And they work when they work, and then when they don't, they're a major disappointment. So.
Yeah, I agree. I've had a lot of friends that used to shoot them, and because, like you said, they work great some of the time. They just have more potential failure modes, and it seems like eventually everybody has one of those. And either you say, well, yeah, that's acceptable to me, or you move to something that doesn't have that failure mode.
Yeah. Well, and I'm also looking now at blades that are just built like a tank, nothing flimsy or weak, or it's just reliability and that sharpness again. If I can get an entire arrow diagonally through a big animal's body and out the other side, 2 holes, so much wound channel throughout, it didn't stop at 6 inches or 12. I mean, it's just devastating.
We had a guy post a picture on our Instagram. He had a frontal shot, and it went out the hind quarter, and it's sticking out about a foot out of the hind quarter on a bull elk this year. So.
Exactly. I mean,
that's what you want.
That's what you want.
Yep.
And so it'll be cool giving these a shot. So thanks, Bill. Appreciate you coming on the podcast, man.
Giving them a try, and let me know what you think.
Definitely. Will do.
All right. Thanks a lot.
Stay gritty.